Is this the first page?
Yes, I believe so. Yes, it is.
Okay, I did notice there was another page that had the instructions.
Yes, I also have it, so I can just read them to you if you would prefer that.
Good. Yeah, that's easier than me having two pages open at once, I think.
Okay, I'm sorry about that.
That's all right. So what do we need to do here?
The first one is number 16.
All right. Now, when they talk about standard form, first of all, when you talk about parabolas as conic sections, it's a little different than when you talk about parabolas as quadratics. They're both the same, but the standard form that's used is frequently different. Does this look familiar?
I believe so. It's not like a circle?
No, that's a parabola.
Oh, okay.
But it's different. In other words, this is kind of the standard form of a conic section parabola.
Okay.
Or and the reason they give it to you differently with this thing called P is because when you look at a parabola from a conic section perspective, you have the focus, which we never knew that existed before. And the distance from the vertex to the focus is what P is. Okay? Now, not everybody gets this format. Some people still get this format. And tell me if you do. In other words, they are given this format, which is standard vertex format. In fact, I can add the K over there so that I get like this. And then they're told that A equals 1 over 4P. So there's two ways this is taught. That's one way. This is another. And I'd rather go with the way that you've been learning. I just don't know what it is. So it's going to be one of these two formats. Now, go ahead.
It would probably be the upper one.
Okay, good. I hope
We've done a little bit of each, kind of ironically.
Yeah, well, this is the standard format for vertex format of a quadratic. And you certainly can tell where the vertex is here, but it's harder to tell where the focus is if I use the bottom one, because I got to use this other conversion down there. Okay? So notice is all they've done is they've multiplied both sides by 4p to get this up here. So let me erase the bottom one so I don't confuse you. Now, the difference between the top one and the second one. The top one is of the form y equal x squared. It's either a parabola that points up or a parabola that points down.
Okay.
The bottom one, notice, is of the form x equal y squared. And those are sideways parabolas. In other words, that could be a parabola that points that way or a parabola that points that way. But they're definitely different. And notice the bottom ones are not functions. They're relations. They're still worth studying. There's nothing wrong with a sideways parabola. But they do not pass the vertical line test, so they are not functions.
Okay.
So when your assignment says put it in standard format, I'm going to guess that this is what they're talking about.
Okay.
Okay. And hold on a second. Let me get everything up here. Yeah, hold on. If I can, got to snap that left. Click on that. There we go. And you're supposed to start on 16.
Yes.
All right. Well, the very first thing you can tell about 16 is that it's the top type of parabola. It's a parabola y equal x squared of that format. It's not x equal y squared. So it's what I would call a vertical parabola, where the line of symmetry is a vertical line.
Okay.
Okay. So, and they want us to identify the vertex, the axis of symmetry, and the direction of the opening. So we'll do all of that. But we got to put it into that format right there. If that's what they're calling standard format. So the first thing I want to do is complete the square on the right side so that I get that part there.
Okay.
And then whatever my A is, I'm going to move it to the left side to convert it to 4P. You always know that A equals 1 over 4P, and also that means P equals 1 over 4A. So those two relationships hold true. Now, in order to complete the square here, what do I have to do?
We have to set the A value equal to 1.
Okay, and how do I get the coefficient of the x squared to be 1? That's what I want to do.
Okay. So we have to square root, divide the right side and the left side by 6.
Okay, let's back up a second. What if I factor out the minus 6 from the first two terms only? So get this. Now, I have not changed anything, have I? In other words, row 2 is the same as the function was. You get that?
Yep.
And that's always the goal. You never want to change anything. When you're manipulating these equations to get them in a different format, you don't want to change anything. Well, now we have to complete the square. Well, how do I complete the square inside the parentheses?
We take, what is it? A divided by 2 squared?
Not A, the coefficient. B? Well, and technically it's not A or B. It's not the same as this A over here when you keep saying A. Typically for a quadratic, A is the coefficient of the x squared, B is the coefficient of the x, and C is the constant. But this A over here is different, completely different. That's not the same A. So let's not mix up our terminology. What I'm going to do here is complete the square. And the way I do it is by taking half of the coefficient of the x term and squaring it. So I take half of this 6, square it, add it to there. Now when I wrote that plus 9 in, how much did I add to the right side of this equation? I actually subtracted 54. Because when I wrote plus 9 in there, that plus 9 is being multiplied by this minus 6 that I factored out.
Oh, okay.
Okay, so what I'm really doing is subtracting 54 from the right side, which means I've got to add 54 to counterbalance it. In other words, this total here is still exactly the same as that. In other words, if I go backwards and I take away 54, take away that 9, I'm getting back to that function. In other words, I still haven't changed anything.
Okay.
And you want to be checking at every single step. In other words,
Okay.
every time you make a change, or excuse me, make a new row, then you want to make sure it's the same as the old row. And in this case, it is. Okay, now, the advantage of having completed the square is that I can now write that as x plus 3, which was what I got when I took half of that coefficient, quantity squared. Combine those two terms, and I get 46 plus 46 equals y. So I'm getting closer. I actually now have it in the original, what was called vertex format. In other words, if I want to, where's the vertex? Once I got it in this format, I know where the vertex is.
Right.
Where is it?
It's going to be the the right side, the
What's the
x minus h.
What are the coordinates? It is h and k. In other words, here's the vertex format. Y equals a times x minus h squared plus k. So h and k are the x and y coordinates of the vertex. Well, in this case, h is negative 3.
Right.
You see why? Okay. And
Yep.
k,
Parentheses.
46. So that's the vertex. And in fact, I don't have to take it to this conic section format yet. I will, but not yet.
Okay.
Because first of all, it says identify the vertex. So actually having it in vertex format is a little better. In other words, we know immediately the vertex as soon as I get it into vertex format. Then it says, what is the axis of symmetry? If the vertex is at minus 3 comma 46, where's the vertical axis of symmetry?
Would it be at 43?
It would be at negative 3. Let me show you.
Oh, right. Okay.
Wherever the x coordinate is.
Got it.
In other words, if I'm graphing, oh man, sorry, hold on.
No, it's fine.
Okay, if I'm graphing this, then I'm going to start at minus 346, somewhere like there.
Mm-hmm.
I also know that it opens down, right?
Right. Because of the negative.
Right. So I'm looking at a parabola that looks like that. Now when they talk what is the axis of symmetry, it's always the vertical line that goes through the vertex. And
so it is always going to be
line is x equal minus 3.
Got it. So in any case where the parabola is positive or negative, facing up or downwards, it would be x, but if it were facing right or left, it would be the y value?
No? Well, we'll get to that in a second. In other words,
okay.
Well, yeah, you've got one on here that's y, or x equal y squared. And we'll talk about that in a moment.
Okay.
But first of all, to answer their question, all we needed so far is the vertex, because the vertex gives you not only the x and y coordinate, but it also tells you where the line of symmetry is.
Mm-hmm.
Okay, so we've answered the vertex, axis of symmetry, and the direction of the opening of the parabola. So actually 16, I'm a little puzzled by when it says write the equation in standard form. Okay, well let's talk about that. Because this is what we got when we put it in vertex form. right there. Okay. Now, I'm not sure what they mean by standard form. This is definitely standard vertex form. But the form they might have meant would be this one. This is considered standard form for a parabola that is a conic section. In other words, if you want to know where the focus is and the directrix and all that stuff, this is a better form because it tells you how far the focus is from the vertex. That's what P is.
Got it.
Now, how do I get from vertex form to this, which is standard form? Well, notice that when it was in this form over here, this was little a. And I say little a, it's not the same as your a in a quadratic. But it's the a if your standard form is like this. Okay? In other words, the a is minus 6.
Okay.
Well, the thing that I know is a equals 1 over 4p. So if I divide both sides of my equation by a, in other words, if I take this equation and I divide both sides by a, it's the same as multiplying by 4p. But first of all, I got to move the 46 over. So I'm going to take this equation and I'm going to make it y minus 46 equals a times x plus 3 squared. And then a is 1 over 4p, so I'm going to multiply both sides of the equation by 4p, and I get that. And that is this standard format that I believe they're referring to, although I'm not positive. Notice that we now have it. It's the same equation. It's just that I moved the 46 and the a to the other side. And now a isn't nearly as important of a value as p is, because p tells me where to put the focus.
Okay.
Okay? So we'll get to that in a second with your additional problems here. What's next on the list?
The next one's 17.
Okay. That's also a y equal x squared. We're going to do it exactly the same.
Okay.
8
after
is
18's the next one.
Okay.
After that.
18 is x equal y squared. Let's take a look at that one. Because that's a different type parabola. That's a horizontal parabola.
Right.
Okay? And its standard format, first of all, they don't even talk about horizontal parabolas when they teach you initially about parabolas. It's all up and down vertical one. But this is our function. And the format that we're trying to get is, in this new format, the 4p is always a multiplier of the term that is not being squared.
Got it.
And the h always goes with the x. K always goes with the y. So this is the standard format for a horizontal parabola. And it's going to involve a very similar process. We're going to have to somehow move the 4 over, complete the square between the y terms, and then take whatever a is and multiply it to get 4p.
Okay.
Okay? So let's do that. In other words, we're going to start by completing the square here. So you know what? Let's start by moving. No, let's do it. I don't want to do it a different way. I will confuse you. But one thing I got to do is factor out that 1/3. I cannot complete the square until the coefficient of the y squared term is 1. What's the next term?
If we're taking out the 1/3,
Divide 3
1.
by 1/3.
1. So just y.
No, divide 3 by 1/3. You got to flip the bottom and multiply. You get 9y.
Okay.
And always check. In other words, is that what we started with? Yeah, we started with 1/3 y squared minus 3y. That's still what we got.
Okay.
Still got the plus 4 over here. Okay. So, hold on. Let me make a little room. Blow this up so I have room to write. Okay, now let's complete the square again. A little tougher to complete the square this time. Take half of this coefficient, the coefficient of the y term, and square it. And it's always added, because even if it's a negative number, when you square it, it becomes positive.
Right. Okay. So 20.25?
No, half of 9 is 9 halves. It's better to leave it as a ratio.
Okay. Fraction?
If you leave it as a ratio, it's easy to square. That becomes 81/4. Okay?
Okay.
See where I got the 81/4?
Not necessarily.
Took half of 9, which is 9 halves, squared it.
Oh, okay.
Square the numerator, square the denominator, that's where you get 81/4.
Got it.
Okay? Now the question is what do I got to balance it with? I can't arbitrarily write in a number into a function and have it be the same.
We have to subtract the 81/4 on the other side.
Not the other side, the same.
Or the rightmost part.
And yeah, and that kind of matters because later on when you complete the square, you will be doing it to the other side. So you got to remember, if you're doing it to the other side, then you're adding an equal amount. If you're doing it to the same side, you're subtracting an equal amount.
Okay.
So how much do I have to subtract?
81/4.
It's not what I added. What I added was 1/3 times 81/4.
Oh.
In other words, you always have to consider this number that you factored out because that thing is multiplying every term that's in the parentheses. So really, when I wrote 81/4 in there, I was really adding 81/12. So I'm going to subtract 81/12.
Got it.
Okay. Now let's continue on. That 1/3 is going to be what used to be called A. This is y minus, it's always whatever you got when you divided that middle term by 2. In other words, by definition, by completing the square, you can write it as a linear term squared. Okay.
Okay.
Well, 4 is 48/12, right? So 48/12 minus 81/12 is 33/12. So now that is exactly the same as what I started with up here. I have not changed it, I've just rearranged it.
Okay.
And I'm really close to vertex format. In fact, I am. This is vertex format. And
right, because
for this problem, we don't need to put it in the P format because they're not asking about the focus or the directrix. In other words, the only thing they care about is the vertex and the line of symmetry and whether it opens up, down, right, or left.
Got it.
So, first of all, where is the vertex?
It's going to be 9 halves and negative 33 twelfths.
Okay, this is actually going to be the x-coordinate.
Oh, okay. Oh, because it's
That's h.
it's equal to x.
That's h.
Okay. Right, they reverse. Okay, so then negative
33 twelfths, and then the y-coordinate is actually going to be a positive 9 halves because this is supposed to be y minus k. So k is 9 halves. So right about there is our vertex, which is minus 33 twelfths, comma, positive 9 halves. Should it open up or down?
It is going to open up.
Yeah, which means this thing zeros. Excuse me. My mistake. This is a horizontal vertex. And the fact that that's a positive number means it opens to the right.
Got it.
So
towards the positive side.
Yes, yes. If it was a negative number, it would open to the left.
Okay.
So right is positive, left is negative, just like up is positive, down is negative.
Okay.
But in terms of the vertex, I still get it from my equation here. I get it from h and k.
Got it.
Okay. Where's the line of symmetry? What's the equation of that line? And that's my line of symmetry on a horizontal parabola.
Would it be the 9 halves?
It's the equation. It's got to be the equation of a line. Yes, correct. Y equals 9 halves.
Got it.
Because it is a line. It's not a point.
Right. Okay.
You need the equation of a line. And they're going to want to know, does it open right or left? And we see that it opens to the right. So these problems, 14 through 19, don't really want to know anything about focus, vertex, directrix, all of the stuff that they're asking in the problems 26 through 31. And the moment we get to one of these problems, we probably want to write this in the more standard form for using the P.
Okay.
We wouldn't have to. In other words, you can always solve these problems using vertex format, which uses the little a. You just have to know that little a equals 1 over 4p. And then you can always solve for p. Okay? I've always thought that it's actually less confusing to students if you stick with the old format. But nobody does it. Everybody seems to be with this new format. I'm not sure why, but that's what they do. I suspect that's what your school uses, is the P.
It is.
Not the little a. Okay, so if I wanted to put this last one into this format, what I need to do is move the h on the other side, for starters.
Okay.
So it becomes that. And then I'm going to multiply both sides by 3. So the right side is left with just y minus k squared. Okay?
Okay.
Now, the advantage of having it in this format is that we still know where the vertex is. We still know that's the h-coordinate of the vertex and that's the y-coordinate of the vertex. So we haven't lost the essence of the vertex format, but most importantly, if our standard format is 4p times x plus 33 over 12, equals y minus 9/2 squared, well, then 3 must be equal to 4p. 4p equals 3. See why?
Because it's in the same location?
Well, yeah. In other words, this is our standard format, and this is what we ended up with. So therefore, 4p is the coefficient, and 3 is the coefficient, so they're equal. And what that makes is p equals 3/4.
Got it.
What that allows me to do is now, where was that? That thing was up here somewhere like that.
Mm-hmm.
Well, that allows me to tell where the focus is, right there. It also allows me to put a directrix.
What is the focus?
The focus on a parabola is the point. No, let's talk about that. They don't teach you any of this when they first teach you about quadratics.
Mm-hmm.
But parabolas have a very interesting property. And that is that all vertical rays coming in that strike the parabola reflect to the focus.
It's almost like a physics.
In, well, this is why they use parabolas to look at stars.
Got it. Okay.
All of the starlight's coming in vertically, and then it bounces to exactly the same point, the focus, no matter where it hits. If you build a telescope with a parabolic shell, you take this parabola and you rotate it around the y-axis, you have a three-dimensional parabola. And you go out and look on the rooftops on everybody's direct TV dish, they're parabolic shaped. You'll also notice that right about there, there's a big receiver.
Okay.
And they're pointed at the satellites. And the data or the information from the satellites essentially comes in vertically, hits the parabolic shape, reflects to the focus, and so this is where you put your receiver.
Got it.
And it works in reverse. This is how they build a flashlight. They put the bulb right there.
Right, okay.
All of the rays that come out of the bulb reflect perfectly vertically. So all of that light doesn't disperse, it gets reflected and goes directly vertically out of the flashlight. And that's why all of the light focuses into a narrow path, and it works. So parabolas are fantastic things. I mean, I should say the focus of a parabola is a great discovery because it tells you where everything reflects to. Now, there is a definition for a parabola that's a little different than you've ever learned before. And what it is it's the locus of points that are equidistant from the focus and the directrix. In other words, if I pick a point on my parabola, like right there, that distance is the same as this distance measured vertically.
Okay.
No matter where I'm at. If I'm down here, then that distance is the same as this distance right there measured vertically. If I'm over here, that distance is the same as this distance measured vertically. So, and as long as your point is on the edge of the parabola, or you can say as long as it's on the parabola, then that's going to be true. It's going to be equidistant from the focus as it is this directrix. Now this directrix is kind of an imaginary line. We don't generally have it when we look at a parabola. But that's why I drew it as a dotted line. It's just conceptually there. In other words, there is a horizontal line where every point on that parabola is the same distance from the horizontal line as it is the focus. And that is the proper definition of a parabola. And then it doesn't really matter whether it's a vertical parabola, a horizontal parabola, and guess what? You can have parabolas like that also.
Okay.
That are rotated by some angle. In fact, all conic sections are like that. You don't, how much conic sections? Have you studied clearly circles, I would imagine?
Yes, all four of them.
Ellipses and hyperbolas?
Yes.
Okay. Well, normally when you study conic sections in high school, you get ellipses that are either horizontal or vertical. But ellipses can also be like that.
Okay.
It's just the math is extremely complicated, so you don't generally get into that in high school. And the hyperbolas are typically horizontal. Sometimes they're vertical, but the most famous hyperbola that you learned in 8th grade was this one right here. This is 1 over, that's y equal 1 over x. That's a hyperbola. It's just one of these traditional hyperbolas rotated 45 degrees. It ends up simplifying the formula amazingly, because a typical equation of a hyperbola that's either horizontal or vertical is like y minus k squared over a squared minus x minus h squared over b squared equals 1. Well, that's pretty complicated. And this is what the equations of horizontal or vertical hyperbolas look like. Oddly enough, if you rotate it exactly 45 degrees to what I have here in the upper left, you still have a hyperbola and a far simpler formula. That's why that's the first one they teach you.
Got it.
All right. Let's go on.
Okay, the next one.
If it feels like we're moving through these slow or not. Conic sections are, it's almost like I would say an hour for each conic section. You almost need an hour for parabolas, an hour for ellipses, an hour for hyperbolas. Maybe not circles. Circles are the easiest ones of all. But yeah, this material is fairly lengthy. I rarely cover conic sections in 1 hour session with a person. So 19 is back to x equal y squared, same as 18. Mm-hmm. We're going to do it the same way. We're looking at a horizontal parabola. Mm-hmm. In fact, we can even know that it opens to the right because that 2/3 is a positive. Without doing anything, I know it opens to the right. What's that?
We're not doing 19, actually.
Okay, what's next?
The next one is 22, but it's on a separate document. It's not this one.
Okay.
It should be the next one on the list.
Uh-oh, hold on. Did I close? No, okay.
Sorry.
It's all right. They want the equation of that circle?
They do, yep.
Well, when you're dealing with conic sections, the best way to start out is always with the general formula. What's the general formula for a circle? If you're going to memorize anything in conic sections, this is what you want to memorize, is the general formulas of each one. X minus h squared plus y minus k squared equals the radius squared. It's the simplest one of all.
Got it.
Where h and k are not the vertex, they're the center of the circle.
Got it.
Okay, so let's fill in everything we know. We're looking at the center of the circle. We can figure out where it is. So what do I know at this point? X what?
The vertex is at 4, -6.
Not the vertex, the center.
Or the center, sorry.
That makes the x coordinate of the center be 4, or h. That's what h is. And k is actually -6. So I need to make that +6. You see why it has to be a +6? Because the standard is y minus k.
Oh, okay. So you have to invert it.
Everything in math is x minus h, y minus k. You don't get to an x plus h until you get to calculus. So if you're not taking calculus, everything is minus. The vertex format for a parabola is x minus h. Ellipses are x minus h. Hyperbolas are x minus h and y minus k. I can't think of anything that's a plus. Even the standard vertex format for a parabola, which is this. Now you might say, well, there's the plus k, but not really, because that thing started on the other side and it was y minus k to begin with.
Right.
They brought it over and that's what turned it into a plus k. But just remember that if you're trying to figure out whether something's plus or minus, in this format, it's minus, which means h is a +4, and k has to be a -6.
Right.
What's r?
R is the radius,
Okay,
which is
situation.
We need to use the distance formula.
Now, it's a vertical line. In other words, it's the distance from the center straight up to the y-coordinate at the top. What's that?
Okay. 10? No, 15.
14.
14. 14, yep.
It's 8 minus a -6. In other words, it's 8 from there to there, and it's 6 from there to there. So it's 14.
Got it.
So it's 14 squared, whatever that number is. But there is your equation. 14 squared is what? 296?
196.
196. So there's the equation of the circle.
Okay.
Now what's that point over there for?
Which one?
At -5, 5.
Oh, that's kind of a random point, but it's on the outside. So it shows the radius. So if we didn't,
Okay, so
we didn't have like a vertical line.
couldn't have drawn a straight vertical line to figure out the radius. We would have used the distance formula between that point and this point.
Right.
Notice that's going to come out to be 14 also. The distance formula is the difference between the x-coordinates squared plus the difference between the y-coordinates squared. What's that? 81 plus 121. That is 202. Square root of 202 should be the radius. Did I make a mistake in my math here? That's 9 between the x's. It's 11 between the y's. It's 81 plus 121. It's 202. How come I don't get 196?
Are they in the opposite locations?
No, I tell you why I didn't get 196. Is I assumed that this was the radius. Hold on, I got this new tool here. I assumed that was the radius. And not necessarily. In other words, do I really know that that's the, is that line tangent to that point? And I don't know for sure. In other words, I'm assuming a lot when I assume that's the radius. If If I really want to know what the radius is, I use the distance formula between those 2 points right there.
Got it.
Notice when I use the distance formula, I got a different number. I got square root of 2 over 2 as opposed to square root of 196. In other words, the first radius gave me 14, but the square root of 202 is a little bit longer. It's 14 and change. So that's what that point's doing there. It's allowing you to calculate the radius perfectly, as opposed to what I did the first time, which was estimate the radius. Sure looked like that should be the radius, right? I mean, looks like the radius got to be the length of that vertical line, which is exactly 14. But I can't really tell where the top is.
Right.
On that. Not accurately, I can't. So I can't use that as the radius. I got to use the point that they have labeled and the distance formula. And surprisingly, I get a different number. And I am surprised, because that sure looks like the radius should have been 14. All right. This the only problem on this page?
Yes. The next one is 28, which would be the next page over.
Okay. Which one? 28?
28.
Okay. So write an equation for the circle given the endpoints. Okay. Can never hurt here to kind of draw a picture. And the endpoints are, let's see, I suppose the better thing to do here is to label the axis first. 18, 11. So I'm going to call that 18, 11. Don't need to do a real accurate job when you're just drawing a picture to get an idea how to do the problem. In other words, I certainly don't need to mark up the grid and measure that. The other endpoint is minus 19, minus 13. No, minus 19 must be about here, minus 13 must be about there. Minus 19, minus 13. So we've got a circle. The endpoints of the diameter, well, that's the diameter. So the circle must look like this, right? Okay. What's the first thing we need? We know what the general formula for a circle is. What we need is the radius and the center. If we have the radius and the center, we'll be done.
The midpoint formula?
Good. The midpoint formula gives you the center. Where is
it? Let's see. X plus 1.
Yeah, add the two x coordinates and divide by 2.
Divide by 2. Okay. Okay, so negative 19 and 18, it's negative 1 over 2. So negative 1/2.
That's the x coordinate. What's the y? Process.
Negative 2 over 2. So negative 2.
Negative 1.
Or negative 1, right?
It's, you add the coordinates and divide by 2.
Got it.
Okay. So that almost answers the question. In other words, now give me as much of the formula as you know.
Well,
remember, it's x minus h squared plus y minus k squared.
So x plus 1/2 plus y plus 6
Squared plus y plus 1. In other words, this number equals r squared. Well, we don't know what r is yet, right?
We need to use the distance formula for that.
Correct. Now, I can do this the hard way or the easy way. If I use the distance formula from either of these points to that center, I'm going to get involved in fractions. I don't want to be involved in fractions.
Mm-hmm.
How about we find the distance between the two endpoints? Whatever that comes out to be, we'll cut it in half, and that's our radius. That's got to be easier.
Mm-hmm.
So the distance formula is difference in the x-coordinates squared minus 1 squared. Excuse me, that's not the difference in the x-coordinates. The difference in the x-coordinates is 37 squared. I don't care if it's a negative or a positive. I'm going to square it, so it doesn't matter. Because all I need is the raw distance between the x-coordinates. In other words, the distance between 18 and minus 19 is 37 units. And the distance between the y-coordinates is 24 units. So this is a much easier calculation than doing the distance using this fraction of minus 1/2, especially since I'm going to have to square it. Do you have your calculator? Can you give me some numbers here?
Yep. Give me just 1 second.
You know this is not going to come out to be a round number just because I got this minus 1/2 there.
Right.
At least I don't think so. I suppose it's not impossible now that
44.1.
That's what D is?
Yes.
So half of that is 22.0. That's the radius. So my square that, what do you get?
486.25.
So there's your formula.
Got it.
Instead of r squared, it's 486.25. Okay. What next?
Next one is 43.
43?
Yes, it's probably going to be in the second email.
Okay. We only have 5 minutes, and I do have a 5:30 I'm going to have to go to.
Okay, no problem.
We'll go as far as we can here. What is it? 40 what?
43.
Okay. These are always fun problems. Actually, I mean that.
Okay.
Probably thought I was being facetious, but not really.
Yeah. Okay.
Here what they're doing is giving you the polynomial. And they want to know, what is this thing? Is it a parabola? Is it a circle? Is it a ellipse? Is it a hyperbola? Not only tell me what it is, but put it in standard format. Is that what the instructions are here?
Yep, that's it.
Okay. So the first thing you want to do to put it in standard format is pretty much move everything on one side and gather your x's together, gather your y's together. Okay. So I'm going to try to draw on this thing, x squared plus 14x plus y squared plus 6y equals, we'll leave that number over there for the moment. With me? Again, we're just rearranging, intent upon not changing anything. Now, put parentheses around that, complete the square. Put parentheses around that and complete the square. So the left one becomes what? X squared plus 14x How do I complete the square?
We divide 14 by 2 and square it.
So I'm going to add 49. Since I just added 49 to the left side, got to add 49 to the right side.
Got it.
This time we're doing it on the other side of the equation, so I'm going to add 49 to both sides. I'm not going to add 49 to one side and subtract 49 from the same side. Okay. Complete the square on the y.
9.
Adding 9. So I'm going to subtract. Add 9 to the other side. Now, here, let me go up. Rewrite this x squared plus 14x plus 49 as a linear term squared.
$49 plus 9.
X plus 7 squared is how you write that term right there.
Okay.
And I know I'm going to be able to write it like that because I got it by completing the square. And that's the entire reason we complete the square. Is so
got it.
Write it as a x minus h squared.
Got it.
The y term becomes what?
The y term becomes, we're adding the 6y and the 9? No, we're taking...
Rewriting that as a single linear binomial term that's going to be squared. And you get it, it's whatever you got when you took half, so it's y plus 3.
Got it.
Quantity squared. In other words, y plus 3 squared is this y squared plus 6y plus 9.
Oh, got it. Okay.
And x plus 7 squared is this x squared plus 14x plus 49.
Got it.
Yes, we're getting it into the standard circle format. Okay? Now,
okay.
if I add the 3 numbers I have on the right, I get 8. Well, now tell me what that is. Sorry that I wrote it on top of all this other text, but I hope you can...
No problem. Circle?
That is a circle.
Okay.
With radius square root of 8. Not 8, square root of 8. In other words, this is always r squared.
Got it.
Now, some of these others that just, I gotta go, but I'll give you a little bit of a clue here. If, these are all circles. Yeah, every one of these is a circle. I guess that's intentional. But what would make it an ellipse is if I had, say, a 2 in front of the x and a different number in front of the y squared.
Like an odd number?
Well, they'd be different. In other words, if the coefficients of the x squared and the y squared are different, then it's an ellipse.
Got it.
If there's a subtraction sign here, instead of an addition sign, then it's a hyperbola.
Okay.
And if it's an x squared and only a y, then it's a parabola. If it's a y and an x squared, it's a parabola. So depending on what you're looking at in these polynomials, you can tell instantly what that thing is without doing any additional work. In other words, 45 has to be a circle because looking at an x squared plus y squared and their coefficient of 2 is the same. So that's a circle. If one of these was a 2 and one of them was a 3, that would be an ellipse.
Got it.
All right, Connor. I will let you go, and
thank you very much.
Talk to you next time. You're welcome.
Okay. Sounds good.